Hey everyone, welcome to Neural Notes, show where AI comes alive. Smash that subscribe button and ride the innovation wave.
All right, welcome back. So last time we talked about why just looking inward, introspection, wasn't really cutting it for psychology. Today, we're going to dive into how some really brilliant people back in the 1800s started to flip the script and measure the mind in a totally new, objective way. And that really brings us to the big question, right? How do you measure a thought? I mean, if you can't trust what someone says they're thinking, how on earth do you study the mind like a science? Well, the solution they came up with was just genius. They decided to link those invisible mental processes, like making a decision, to something you could actually see and measure, something objective. And a lot of the time, they did it with nothing more than a simple stopwatch. So let's kick things off with our first case study. This comes from a Dutch researcher, a guy named Franciscus Donders. He was obsessed with decision-making, and he asked a question that, for his time, was just wild. Exactly how long does it take to make a decision? Just by asking how long, Donders was making this incredibly bold claim. He was basically saying that a purely mental event, a decision happening inside your head, has a physical property you can actually measure. It's duration. And hey, if you can measure it, you can study it scientifically. This idea, this was the key that unlocked the door to an objective science of the mind. Okay, so here's what he did. He set up this really clever experiment with two different conditions. In the first one, the simple reaction task, it's super easy. You see a dot, you clap. That's it. But in the second one, the choice reaction task, there's a twist. If you see a dot on the left, you clap. But if it's on the right, you do nothing. You actually have to make a choice. Now, you'd obviously be faster in that first condition, right? Donders knew that. And that little difference in time, well, that was everything. And this is where the genius of his subtraction method comes in. Donders figured, look, both tasks involve seeing the dot, that's perception, and clapping, that's a motor response. But that second choice task, it adds one extra hidden mental step, the decision itself. So he thought, what if I just subtract the simple time from the choice time? What's left over should be the time it took just to decide. It's so simple, but so powerful. And this was absolutely revolutionary. Think about it. Donders wasn't just measuring how fast someone could clap their hands. He was timing thought itself. For the very first time, he proved that a hidden mental process could be pinned down, measured objectively. This really laid a cornerstone for all of modern cognitive psychology. All right, so around the same time, there was another pioneer, Hermann Ebbinghaus, who was tackling an equally mysterious mental process, memory. And just like Donders, he was absolutely determined to quantify it. So Ebbinghaus wanted to answer a pretty simple but really profound question. How fast do our memories fade? We all know it happens, right? But is it just random, or does it follow some kind of predictable pattern? To figure that out, he needed a solid, objective method. Okay, I gotta say, his experiments must have been incredibly boring to do, but they were brilliant. He had participants, and honestly it was mostly just him, memorize these long lists of random nonsense syllables, things like GHK or FIB. He'd record exactly how long it took to learn them perfectly. Then he'd wait, maybe a few minutes, maybe a few days, and then he'd measure how long it took to relearn that same exact list to perfection. And he called the difference between that first learning time and the second relearning time savings. It's a great name for it, right? Think about it. If it takes you less time to relearn the list, that means some of the original memory must still be there, saved in your mind. So the amount of time you saved became his objective way to measure the strength of a memory. So what happened when Ebbinghaus plotted all this savings data against the time he waited? Well, he made his most famous discovery. A clear, predictable pattern popped up every single time. The forgetting curve. It showed that we forget stuff incredibly fast right at the beginning, but then that process slows way, way down. And whatever you still remember after a few days, that stuff tends to stick around for a really long time. And just to give you a sense of his unbelievable dedication to getting objective data, it's estimated that Ebbinghaus, who remember was his own main test subject, put himself through about 40,000 of these memorization trials. 40,000, can you imagine? That is an almost unbelievable commitment to science. Okay, for our final example, let's talk about a pair of German researchers, Weber and Fechner. They turned their attention to another mental process, our perception of the world. And yeah, you guessed it, they were also determined to turn it into an experimental science. let's try a quick thought experiment here. Imagine I hand you two empty envelopes, but I've secretly slipped a quarter into one of them. Could you feel the difference? Tell which one's heavier? Yeah, probably. But now, what if I did the exact same thing with two really heavy hiking boots? Suddenly, trying to feel the weight of that same quarter becomes pretty much impossible. So, why is that? Well, what this whole thing demonstrates is that our perception of change is relative. It's not absolute. And that is the core of what's known as Weber's law. Basically, the more intense a stimulus already is, like a heavy boot or a really loud room, the more it needs to change before we can even notice a difference. They had discovered that a fundamental part of how we perceive the world could actually be described by a predictable mathematical rule. Okay, so let's pull back for a second and look at the big picture. We've got three incredible examples here of pioneers who each found an objective, measurable way to study a different piece of the mind. You've got Donders, who showed decisions have a measurable duration. You've got Ebbinghaus, who showed that memory fades along a predictable curve. And you've got Weber and Fechner, who showed that our perception follows mathematical laws. Together, they proved that these internal processes weren't just some philosophical mystery. No, they were things that could be scientifically measured and understood. They were laying the groundwork for a real experimental science of the mind. And check out the dates here. We're talking the 1860s, 70s, and 80s. I mean, it really feels like cognitive psychology is in great shape. It's ready to just take off, right? But here's the thing. It didn't. Yeah, if you pick up any textbook on this stuff, it'll tell you that the cognitive revolution, the big boom, didn't actually happen until the 1950s or 60s. That's almost a whole century after these amazing foundational experiments were done. So that leaves us with this really fascinating historical puzzle. If all these amazing first steps were taken way back in the late 1800s, why was there this huge gap, almost half a century of not much progress in this area? What on earth happened in that gap? Well, that's exactly what we're going to find out in our next explainer.